Hello everyone. In this session we are going to see about problem on cantilever beam with concentrated load only. Concentrated load is nothing but point load. So this problem is from the unit 2 shear force and bending moment in beams from the paper strength of materials for mechanical engineers. So the given problem is a cantilever beam 1.5 meter long carries a load of 2 tons at its free end and another load 1 ton at a distance of 0.5 meter from the free end. So draw shear force and bending moment cantilever beam. Assume 1 ton is equal to 1000 kg and 1 kg is equal to 10 Newton. So first thing is a cantilever beam. So one end is a fixed end and another end is a free end and carries a load of 2 tons. So here 1 ton is equal to 1000 kg and given that 1 kg is equal to 10 Newton. So 2 ton in terms of kilogram is 2000 kilogram. So 1 kilogram is 10 Newton, which means 2000 kilogram is equal to 20,000 Newton. So that may be rewritten as 20 kilonewton. And another load 1 ton at a distance 0.5 meter from the free end. So from the free end 0.5 meter, again a load of 1 ton is there. 1 ton similar to 20 ton 20 kilonewton, it can be renamed as 10 kilonewton. Right. So draw shear force and bending moment diagrams for this given cantilever beam. Right. So given data. So what are all the data given? Cantilever beam and then load at B 2 tons, that is 20 kilonewton. Load at C 1 ton, that is 10 kilonewton. So இது எப்படி நம்ம calculate பண்ணோம் அப்படின்னா in the given question 1 kilogram is equal to 10 Newton. So RA will be the vertical component, that is reaction, and MR will be the moment reaction. So as we know that summation of forces at Y is equal to 0, which means reaction at point A is equal to the point loads or concentrated loads, since it is assumed in anti-clockwise direction. Hence at point B there will be 1 ton, that is 10 kilonewton, so minus 10, and at C 20 kilonewton, so minus 20, which gives RA is equal to 30 kilonewton. Reaction at the point A is equal to 30 kilonewton, and then summation of moment is equal to 0, which means MA or MR, reaction at point A, moment reaction at point A, MR. So moment calculate பண்ணும்போது load into perpendicular distance இல்லையா. So first point moment at point A considering reaction minus load is 10 kilonewton into perpendicular distance 1 meter, again minus 20 kilonewton at point C at a distance of 1.5 meter, which is equal to 0. So moment reaction at point A is equal to 40 kilonewton from the calculation. And then shear force. So shear force is nothing but VAL is equal to 0. So VAL is nothing but shear force at point A by considering load only. So fixed point இல்லையா, so அந்த pointல load எதுவும் இல்லை, so 0. When considering reaction at the same point A, shear force at point A considering reaction 0 plus 30. This 30 comes from this reaction at point A calculation 30. So shear force at point A considering reaction is equal to 30 kilonewton. So this will be carried over, which means when considering load only at point B, shear force at point B 30 kilonewton, and then when considering shear force at point B both reaction, which means 30 kilonewton from the previous, and then minus 10 is nothing but that point load, that concentrated load is nothing but 10 kilonewton at point B, so which gives 20 kilonewton. And then at point C, shear force at point C considering load only, this load will be carried over, so 20 kilonewton, and then the same point shear force at point C considering the reaction, which gives 20 minus 20. This minus 20 comes from the 20 kilonewton at point C. Minus is for anti-clockwise direction, and hence shear force at point C considering reaction will get 0. Now at bending moment. So bending moment at point A considering load only 0, and then bending moment at point A considering reaction, the load at point A, which is equal to 40 kilonewton, that is comes from this moment reaction. So minus 40 kilonewton. For anti-clockwise direction, negative is used. And then at point B, this minus 40 will carry over plus 30. 30 is come from this point. So as we are calculating bending moment at point B, we should take load at point B from this shear force calculation. So at point B bending moment, this minus 40 will carry over from point A plus 30 from the shear force at point B calculation at a distance 1. So bending moment is nothing but load into perpendicular distance. So this load 30 kilonewton at point B from the shear force calculation into the distance, perpendicular distance will be 1. So you can see that in image by rewinding the video. So by solving this, we will get minus 10 kilonewton. And at point C, this minus 10 will carry over plus the perpendicular distance will be 0.5 from the free end, and the load will be 20 at point C. This 20 is from this VCL, which is shear force at point B considering load only. So on solving this, we will get 0. So now we are came into the diagram of shear force. So this will be the given cantilever beam. This is a free body diagram. This will be the fixed end and this will be the free end. At point B and point C there are concentrated loads or point loads at a distance given in the question. So the anti-clockwise direction, and as we calculated, reaction at point A is 30 kilonewton and moment at point A is 40 kilonewton meter. So VAL shear force at point A considering load only, there is no load, so 0. So VAR is nothing but shear force. V is shear force. So shear force at point A considering the reaction, which is equal to 0 plus 30 is 30 kilonewton, since this is in positive direction. And then VBL shear force at point B considering load only. So 30 kilonewton. This 30 kilonewton from point A will carry over. So considering the load only, the same 30 kilonewton is available for point B. And then VBR is shear force at point B considering the reaction. So 30 kilonewton is the load, and then reaction is nothing but that's point load or concentrated load gives. So minus 10 as because of anti-clockwise direction, 30 minus 10, 20 kilonewton. At the point C, considering load only, this calculated 20 kilonewton will carry over. And considering the reaction at C, shear force at the point C, considering reaction, this 20 kilonewton minus this point load 20 kilonewton. Minus is for anti-clockwise direction, hence 0. So the diagram will be drawn as in x direction the distance and y direction the shear force, calculated kilonewton. So 30 kilonewton V at A considering reaction, so is 30 kilonewton, and VB at L, which means considering load only at VB, that is shear force at B is same 30, and hence a straight line will be drawn. And then considering VBR, that is reaction force at point B, the answer will be 20, hence the vertical line will be drawn. And then VCL, that is shear force at point C considering load only, the previous calculated load will be carry over, so 20 kilonewton same, again a horizontal line will be drawn. Again VCR is nothing but calculating the reaction with the shear force at point C. So 20 kilonewton is a calculated value from the previous, and then 20 is nothing but this point load. So 20 minus 20 will get 0, and hence a line is drawn. So on closing this, we will get shear force diagram for this given cantilever beam. So this will be the shear force diagram for the given cantilever beam. Now we are calculating the bending moment. So this will be the previous part, the same, and then now we are calculating bending moment. So bending moment at point A will be 0, that is considering load only, and then bending moment at the same point A considering the reaction also. So 0 minus this 40 kilonewton. It's a calculated value from the first line, right? So minus 40 kilonewton, and then bending moment at the point B is this minus 40 Newton plus 30 is nothing but the shear force load at the point B calculated from the shear force that is in the previous slide. So 30 into distance 1. So 30 into 1, 30, minus 40 plus 30. On solving this, we will get minus 10 kilonewton. Hence a line is drawn. And then at point C, minus 10, this calculated value plus the perpendicular distance is 0.5 and the load will be 20. This 20 is not the value. The 20 is calculated from the shear force at the point C. The load at shear force calculation at point C is 20. So perpendicular distance is 0.5 into 20, which gives 0 kilonewton. Hence a line is drawn. So on closing this, we will get this diagram, bending moment diagram for the given cantilever beam. I hope the problem is easy for you to understand by this method, and we will see further problems in the next session. Thank you.